Good evening, everyone. Welcome. Wonderful. We've actually starting on time. We are live, and thank you, Emmanuel. Wonderful. Fourth time lucky. We've had ironed out all the bugs, and we are ready to go. So, thank you for everyone for joining us tonight, and hope you are entertained and pick up some tips and find out some very important information on pests and diseases tonight. So, just a couple of club things. Great to hear that everybody enjoyed themselves at the field day, Sunday the 28th of February. Neil stepped in as the host for the day, and he did a wonderful job, so thank you, Neil. Thank you to all the members that came along and helped make tea and coffee, answered questions. We had lots of new members come, so it was really good to see that there was people there to help them and answer questions for them as well. So thank you. Our Thursday volunteer group is going strong. So if anyone is interested in popping up to the club on a Thursday morning from 9 o'clock, we do a volunteer group. We clean up the apiary, the grounds, we do a bit of gardening. There's a few odd jobs around the place that need to be done. We've got a bit of rubbish that we need to get rid of. So please, if you've got a spare time on a Thursday morning, just come up to the club and we'll give you a cup of tea and coffee and some biscuits, and you can have a chat with everybody as well. So we've had some lights installed around the club, which is great news, because for a long time we've just had some fluoros on each of the sides of the club, and they attract a lot of spiders, and so we're always getting cobwebs all over the outside of the club. So we've had some new LED lights installed on sensors, so they only come on when somebody walks past, or if you're coming to the club on a Thursday night, they will turn on to greet you when you come through the gate. That's terrific. So thank you, Ivan, for arranging that. The Easter show is going ahead from Good Friday, the 1st of April, and it goes for, I think, 10 days. So please, if you're going to the 12 days, so if you're going to the Easter show, please pop in and say hello to a friendly beekeeper on the stall. I've had one of our members offer to get some queens for the club, so I don't know if anyone's interested in replacing their queen. Sometimes it's a good idea to do it this time of year so that you've got a nice strong hive going into winter. But if you're interested in getting a queen, he's had a lot of success with the people he's bought them from, and he said they're very nice, calm temperament. They've been very productive queens, so I'm going to stick with his recommendation, and I'm getting one myself. If you would like one, please just drop me an email or a text message, whatever you like, and we'll put your name down for them. Got a school at Oak Flats that needs some help with some hives. We're going to set them up with 2 hives, but we need a little bit of help to move them, for one, from another location to the school, and between Bruce and I, we're having a bit of trouble trying to work out when we can both be available for it. So if anyone else is available that might be able to help out one afternoon and evening, could you please give me a call? Sunday, the field day for the 28th of March. So it'll be going ahead. We're sort of coming out of COVID, and we're looking forward to having a lot more people come to our field day. So we're pretty sure we can get around about 100 people in here. And if you're interested in coming, please do so. And this month we're talking about April's going to be Sugar Shake month, so the last weekend in March is a good time to talk about sugar shake testing with your hive, and it's a part of DPI requirement that everybody does this in April. So we'll be giving away some shakers. We've got some free ones to give away to members, so maybe we might do it to the first come, first served, or we'll keep a couple of spare ones aside for maybe somebody that can answer some tricky questions or something. I think that's about all I've got. Oh, sorry, I have got one more thing. The club has purchased this lovely book on honey and pollen flora. It's from Doug Somerville, and it's a wonderful book. If you're interested in finding out what trees are flowering at different types of the year in your area, it's a great book to have a look through. So it will go into our library tonight, and if you're interested in borrowing it, please come up to the club and see either myself or Matt Reed. He's the librarian, and you can have a loan of it. It's a great book. It looks beautiful, and it's really, really heavy. Not your bedtime reading type book, but anyway. So I think that's all I've got for you tonight, and we will switch over to Bruce. Bruce has been helping us this week do another video. Thanks, Bruce.
Pleasure.
We're talking about how to inspect a hive. So shall we go straight into the video, Emmanuel, or would you like to?
You want to talk about it?
We'll talk about what we did for the video, what we did for it, the first one.
Okay, so the first part of the video, shows the correct way, to inspect a colony of bees for brood diseases, not only American foul brood, but all brood diseases. And it's probably important that people do that, at least in the early spring and again in the autumn. But, if you inspect every weak hive or even strong hives, regularly throughout the year, that's a good idea, because anyone's bees can pick up any of the brood diseases, because bees are free flying, they're not fenced in. There's quite a heavy density of bees in most towns, in the city and in the country, because of the flora that's available. Bees breed well, they swarm a lot, and they get some honey. Commercial beekeepers move to areas where there's an abundance of one species quite often and get far larger crops of honey, but that requires more intense management of colonies. So everyone's hive's at risk of picking up disease. It's not your fault. The beekeepers are the ones that find it. The keepers of the bees are the ones that don't find disease. So tonight we're concentrating on looking at keeping your bees healthy, and you're the one that's responsible, for keeping your bees healthy. And if you find some problem, ask someone that knows, not Joe around the corner or Bill down the street. Go to the biosecurity officer in one of your ABA clubs, or send a sample to New South Wales Department of Primary Industry, and we're going to talk about that in the video anyway.
So Bruce, just coming out of winter, when would be the first time you would inspect the bees coming out of winter?
Oh, look, I think, in most areas, August or September, but if you live in the tablelands, it's probably the end of September.
Yeah.
But if you live anywhere on the coast, August's the best time to do it, because the colony's not that strong. It's easy to look at the brood then, because there's less bees in the colony. And the really important thing, and the point I want to really stress is, shake all the bees off the frames so you see every single cell. That's important.
Bruce,
and it's amazing how you notice something that's different.
You make that look so easy in the video. Bruce just goes and they all drop off. It takes me a...
You've got to catch them by surprise, Penny.
Is that it?
If you just shake a bit, they hang on, because they know something's going to happen. If you just go bang and catch them by surprise, they all fall off.
They just... Pew,
That's
when Bruce does it, yeah. Anyway, you'll see that in the video.
A lot of practice.
You have. Anything else? No. Emmanuel, can we switch over to the video now? Lovely.
Beekeepers, and we're going to talk about how to inspect a hive for the presence of brood diseases. The first thing is to smoke the entrance, and if you give the bees a lot of smoke at the entrance and have a pause and then smoke again, you're going to drive the bees up through the excluder, which means you've got a lot less bees to look at in the brood box. So then remove the lid, puff under the lid, put the lid out of the way, quickly remove the super, and that gets rid of all the bees in the super. If you smoke from the lid down, you're going to drive more bees into the brood box. We then remove the excluder, just check there's no queen on the excluder, which there isn't, and put it upside down on the super. The easiest frame to remove is the frame second from the wall. So we use the hive tool like that, like that, like that. Then we pull out the second frame from the wall. Now, because we're looking for disease, the main thing is to shake all the bees off the brood, and that's important. So just go to the entrance of the hive if it's on the ground. If it's not on the ground, you have to shake the bees back into the box if it's on a stand. So we just go like that. We hold the frame like that, look straight into the cells. By looking straight into the cells, I can see the symptoms of chalk brood and European foul brood. Excuse me, if I hold at an angle, I look at the bottom V of the cell from the top bar to see if there's any symptoms of American foul brood, because the symptoms of American foul brood are on the bottom V of the cell, and with all those brood diseases, chalk brood, European and American, the cells can be perforated, and you'll notice here, there's no perforated cells. Now, it's critical you look at every frame. It's no good just looking at one frame, because the disease can start off anywhere in the colony. I'll now pull out the wall comb, and we'll notice there's no brood on the wall comb, so I won't see the symptoms of any of the diseases if they're present. So I put that back in the hive. I then go to the next frame, shake the bees off, put it out, look into the cells, the bottom V, hold it that way, to the other side, look into the cells and look in the bottom V, and I then proceed across the whole colony, shaking the bees off, looking like that, into the cells, perforated cappings, anything that's unusual I need to note and have a closer look at. Shake the bees off. That's unsealed brood, all healthy. Back again. Next frame. Shake the bees off. Up. A lot of unsealed brood, all healthy. Other side of the frame, all healthy. Again. Shake the bees off. That's a frame of foundation, so there's no brood in that. And the wall comb may or may not, so it's got no brood in it. So there's no need to check that, because the symptoms of the vegetative form of the disease are, present when there's brood present. Then, I can put the hive back together again. Being careful not to kill any bees. Super on. Lid on. Now, it's possible to transmit disease with the hive tool. So after each hive, you should wash the hive tool. Now, if it's thoroughly washed, bacteria can't penetrate metal, so there's no risk of transmitting diseases. And also, you don't want any wax or anything on that hive tool, because the bacteria can get in the wax of all the bee diseases. If you're really worried, you can open the smoker, put the hive tool in the smoker, puff the smoker, get it to flame, and that heats up and burns the hive tool. You can also, wash the hive tool in bleach or soapy water, or use a different hive tool for every hive. Also, it's important to have some water with you. So after you've inspected each hive, it's important to thoroughly wash your hands in case they got sticky or any wax on them before proceeding to the next hive. Okay, so this is a long Langstroth hive, or a coffin hive. So it's built so that you can put Langstroth frames in this type of hive that's off the ground, that's convenient to work, and you can have the entrance at one end and a queen excluder after about 8 or 9 frames, and the honey goes behind, or you can have the entrance in the middle and the bees will have the brood in the centre of the hive, and there'll be honey on each side of it. That's the way the bees will naturally work that if there's no excluders on the hive. You can lift the whole lid up, it comes up like that, and it's normal to have inner covers in the hive to keep the hive cooler than normal. You can take the inner covers off, and that exposes the frames in the coffin hive. So propolis tends to stick them down. Okay, so in the case of this hive, the entrance is on the other side in the centre, so the brood area, covers approximately that area there, and there's honey that end, and honey that end when the hive, is normally working. This hive's been extracted just recently, so there's no stored honey on it. Okay, so if we look at this frame, we'll notice that there's not a lot of capped brood, but there's some capped brood. So that's what we call a patchy brood pattern. And if we poke a stick in, if the hive's got American fowl brood, and you poke it in and you run the stick along the bottom V of the cell, which is critical, from the top bar, the bottom V, and run it along the edge, and you pull it out, you'll notice that that strings out like chewing gum. And that's a typical indication that the hive's got American fowl brood, the ropey stage of American fowl brood. Now, not every cell's going to be diseased, so if I touch that cell there, it doesn't string out at all. That one there doesn't rope out. There's one here that's got perforations in it. That one there's got perforation in it. If I put a stick in there, no, not going to rope. If we look at the frame in that area there, we'll notice there's only a small amount of capped brood, and a number of the caps on the brood have got holes in the cells, like that one there, that one there, that one there. So if we poke a stick in, there's a chance it might string out like chewing gum, too dry. So these cells here, have been diseased, but they've formed a hard, dry scale. There might be a little bit of rope in that one, but not much. Just a little bit. That one's not roping. That's not roping. So they've formed scales because they've dried out. So it's a more advanced stage of American fowl brood. Another example of where the cell will rope a bit. It's not rope, it's roped a bit there. That one there. That's the sure sign of American fowl brood. Bottom V, touch, pull out, don't stir the stick around, just touch it and pull it straight out. Okay. Okay, so a way to get a diagnosis, which is free from New South Wales DPI, is to find a cell that strings out and smear the material on the glass slide. And it's important to get more than one cell to be sure that you have got a representation of the disease in the hive. So you just smear it on like that there, and you just let it air dry. And it's important to put the match back in the frame like that, and put the frame back in the hive like that. Don't throw the match on the ground because there could be a bit of honey on it and it'll attract bees and they'll rob. You let the slide air dry, you then put it into a carrier like that, like so, and you write on the slide the hive number, and you write on the hive number you put on the slide, seal it up, put it in an envelope and send it to the Department of Agriculture at Menangle. So when you take the slide, you need to fill in a form that you can download from the computer and send it to the Department of Agriculture at Menangle, and it's Post Office Box 4008, Menangle, and you fill in the details on the form that will identify you, and it's also got to have your registered number on it. If you're a registered beekeeper, the test is for free, and you get the results back in a couple of days from a slide. Okay, so we're preparing this hive to be killed, and New South Wales CPI recommend petrol to kill hives, and you need about a cupful for a double hive and a bit more for a 3-decker, and about 3/4 of a cup or so, depending on the strength of the hive. The fumes is what kills the bees, not the petrol, so it doesn't have to come in contact with the bees, and it's extremely effective. In this case, I'm preparing the hive to be killed by petrol later on tonight when it's dark, so it's important to do it when it's dark, when all the bees are back in the colony. You don't do it in the middle of the day because bees will drift into other hives. They'll carry bacteria. The bacteria don't affect the adult bees, but they act as the carriers to spread the disease. So by putting rag along there tonight when it's dark, come back and just pour petrol on the rag, shut the hive up, and within about 5 minutes every bee in the hive is dead because the fumes have killed the bees in the colony. We then need to take the bees that are dead out of the box and bury them, and then prepare the hive for irradiation. To prepare the hive for irradiation, we need to put the frames in plastic bags. Irradiation doesn't change the temperature inside when the irradiation is applied to the boxes. The irradiation destroys the DNA in the bacteria, and it kills the spores and any vegetative forms of the disease, but it causes some molecular movement, and if there's any honey in the hive, it can run out. So the hives have to be extracted before they get irradiated, and the frames put in plastic bags to prevent any escape of any honey that may be in the frames. Once the irradiation is completed, you can put the bees straight back in the hive because there's absolutely no residue left. It's 100% effective at killing every spore of American foul brood in that material. Penetrates the wood, penetrates the wax, penetrates the pollen, so the hive is completely safe once it's been properly irradiated at the appropriate 15 kilogray dose or higher. So it's been found petrol is extremely effective at killing bees, and it doesn't leave any residues in the combs or the wax or the pollen because there's been tests carried out to get approval to use petrol. So it's completely safe, and you can put bees straight back into the hive once the material's been irradiated. You use some insecticide, the combs are going to be contaminated and it'll kill the bees when you put the bees back in. There's no need to remove the comb. The temperature only changes 1 or 2 degrees with irradiation, so you can reuse the combs again straight away once the material has been irradiated. To use petrol, it's a dangerous substance. You need to be very careful when you use it. You don't need any naked flames anywhere near petrol. So what you do is you just pour the petrol inside the colony, shut the lid. About 5 minutes, the whole lot of the colony is dead. You then take the lid off, and then you remove the frames to bury all the dead bees. So you've got to vent the material, and by venting it, the petrol fumes dissipate, and it's then not likely to cause any issues with being flammable. But it's important to be careful with petrol because it can explode. So you don't light the petrol or do anything like that. Vent it, before you take it anywhere. That's important. Important because your smoke is hot, to keep it well away, when you're doing this process. You come at night, carefully lift the lid. The bees won't fly much at night, if at all. And if they do, the cold weather at night will kill them anyway because they need the cluster to keep warm. And just pour petrol over the top, shut it. You'll hear a roar. Once the roar stops, the bees are all dead. Okay, so what are we going to use when we do it? The bee smoker. When you lift the lid, you've got to shut the entrance first, right? So shut the entrance first so that the hive is airtight. as airtight as can be. You need the smoker, well lit. When you lift the lid, smoke the bees quickly, and that'll prevent any from flying. You then need, a container with petrol in it, and approximately, the right amount. A cupful for a double, maybe 3/4 of a cupful for a single, and maybe a cup and a half for a 3-decker hive. You need some sort of cloth under the lid, but that's not essential. You can just pour it over the frames of petrol. If you've got a cloth, well and good, and then just pour the petrol on the cloth. But prior to that, you have to have removed all the honey from the hive, because you can't get it irradiated with honey in the frames. You can extract that and keep it separate and mark it as AFB honey. It's not going to affect you if you eat it, but it's not to be going into any pre-packs or be given anyone, so it may have access to other hives if people throw out containers. That's important. So once you've got the petrol measured out, it's handy to have water, just to wash your hands, because you can get sticky, get petrol on it, and water's always handy when you're around a beehive. We're at Illawarra Beekeepers, and we're going to talk about how to inspect a hive for the presence of
Can we start again?
Yeah, sure.
Technical hitch, the camera switched off. Go.
Oh, starting again. Okay, sorry. We got just a little technical hitch there. One of the cameras turned off. Great video. Thank you, Emmanuel. We spent a bit of time yesterday down in the apiary doing that one, so it is surprising how long some of these videos do take, but it's all good. The Emmanuel cuts down all the videos to a sort of a manageable size so that people are happy to sit and watch, and hope 17 minutes is not too long for you. But it's very important information. Bruce, thank you for your wonderful job you do. And yeah, so let's, one of the things we noticed, yes, we were looking at in that video was AFB. So Bruce, can you explain some of the symptoms that what people would notice of their hive before they actually open it up to find that it's got AFB? Is there any symptoms that you might think, oh, I'm a bit worried about that hive?
There can be, Penny, but it's not conclusive, because it's interesting with American foul brood that often the strongest hive is the first hive to pick up that disease. And the reason for that is that they've got so many other field bees compared to the other hives that they can't pitch honey from anywhere, and the spores, of course, are carried in honey, doesn't affect the adult bees. Now, eventually, a hive that gets American foul brood declines in population because a lot of the brood is not hatching. So a symptom, if you look outside the hive, is that a hive has not got a lot of flight activity, which indicates there's not as many field bees in it compared to other hives. So that can be an indication, but it means that the hive's had the disease for a period of time. The other symptom at night, if you go down and a lot of hives are making a noise, ripening nectar, and a couple aren't, that also indicates that they don't have the field bees to collect the nectar that day. So they could be looked at. What I say is to get an idea, if you've got a lot of hives, and this applies more to commercial people, you look at the strongest hive, the weakest hive, any dead hives, obviously, because they've died for some reason, and find out the reason, and corner hives. When bees go out to work, they come home, they're tired. Because they've got food, they can go to any hive. The bees won't kill them if they bring a reward back to that hive. So if bees have been out, they come back, a corner hive, they'll go in. If they've picked up some disease, you'll get a corner hive in an apiary, a weak hive, a strong hive, and a dead hive. But that's just a rough indication. You've got to look at every frame and every hive to be sure there's no clinical evidence of the disease in the hive. Now, the other complicating thing is that the spores or seeds live for 50 years. So they can be in a hive, and until those seeds are planted in the brood, and it's only larvae between 12 and 48 hours age that the seeds or the spores germinate to suit the vegetative stage. So it's possible to have spores in honey. If the bees eat it, it gets extracted, never gets into the brood, a bit like a seed. If I put it in my pocket, I don't wet it, I don't plant it, it won't grow. And the same with AFB spores, they've got to be planted in a larva, 12 to 48 hours of age to germinate for you to see the symptoms visually with your eyes.
Okay. So we'll talk about inside the hive. What are we looking for?
Okay, so what we're looking for in the hive is that we pull the frame out. As we saw in the video, you've got to shake the bees off. That's critical. When we shake the bees off, we need to look at any brood that's not normal brood. Normal brood is pearly white in colour, C-shape in the larval form. The pupal stages are white and they turn to the colour of a bee just before they emerge. The cappings over the seal brood is convex, and if it's concave it means there's a problem with it, it's diseased. And the real telltale story that I think is easy to look at is if the caps have got holes, in the centre of them or offset a bit. And if you take that cap off and it's brown inside or a colour other than normal brood, it indicates that that brood is probably dead or dying. Now, in the case of American foul brood, the symptoms are quite uniform. It's brownish in colour. If you put a match in the dead decaying material, strings out like chewing gum. You don't turn the stick and spin it round a lot because that pulps it and it'll rope out. We saw in the video that the symptoms are always on the bottom V of the cell. That's critical from the top bar. People, and a lady rang me up this week, thought she didn't have AFB. I talked to her. She went back. So when she put the match or the stick along the bottom V, it roped. Prior to that, she was just putting the stick in the cell and missing the decayed dead material. So it's got to be on the bottom V. That's really critical. So you often see perforated cappings first. If you look in a cell and they're on the bottom V, so you need to hold the frame at an angle to look in the bottom V, you see dead material on the bottom V of the cell, brownish in colour. That's a sign of American foul brood. In the case of European foul brood, mainly affects the larval stages. They go yellow in colour, and there's not much seal brood in the case of European normally. And you get European and American in the same hive, complicates things. Chalk brood, just like lumps of chalk, get thrown out the entrance. The only brood disease you can see at the front of the hive. Another thing called sac brood, the pupal stage blows up like a sac, hard skin, and it comes away clearly. The only scale that doesn't come out clearly is in the case of American foul brood. But just look at it, you see holes in the caps, look further.
All right. We've got some more things to talk about with AFB.
So the scales are really stable, Penny.
Yeah.
So each scale, that means that where one larva has died, contains millions of spores, millions. And the spores are called seeds in the plant world, right? And the bees only have to ingest 10 of them and feed to the larva. So what happens is the bees lick the scales, it gets on their tongue, the larval food, the royal jelly, and the food they feed larvae, the spores get mixed up in it. The spores then get planted into the larva and absorbed through the cuticle when the royal jelly goes around the larva of all stages, drone, worker and queen cells, a brood, larva. If they're between 12 to 48 hours of age, the seed then germinates and that larva dies. Now we all know bees are great housekeepers, great females, so they try and clean out that material. By cleaning out that material, they use their tongues and their mouth parts, and they get this bacteria on their tongue and mouth parts. Then they go and feed some more brood. That larva gets infected. So it often starts off with one larva, and then it goes to 2 to 10 to 20 to 50 to 100, and eventually the hive will die out in the case of American foul brood. The spores can also live, in the woodwork, in the wax, in the pollen, in the propolis. So every product in the hive can be contaminated with spores of American foul brood. So it's not only honey that can transmit American foul brood, it's also pollen. So in New South Wales, pollen has to be irradiated to kill any spores of American foul brood that may be in pollen you purchase from overseas or locally, and that irradiation 100% destroys all the reproductive ability of seeds to germinate in a honeybee colony. Might talk a bit about irradiation now. So irradiation was developed by New South Wales Department of Primary Industry by Michael Oninsky. What happened was there was a telecom technician who talked to Warren Jones, who was an apiary officer in about 1980, and said telecom do a lot of irradiation to sterilise equipment. He told me, I told Michael. We went out to Stereotech, which is quite close to this club, knocked on the door. There's a lady there called Pamela Wills, who had 2 beehives, and she was in charge of all the research at Lucas Heights. Terribly cooperative. We'd burnt 200 hives at Young, owned by a commercial beekeeper. We kept 20 hives just to see, what future research we might be able to use those hives for because of the spores living for so long. We took those boxes out there. They irradiated them for nothing, and Michael was able to work out the right dose rate and all that sort of stuff. And we kept them for 2 years, put bees in them. They never got American foul brood. And then a beekeeper at Corindai had 1,000 over 1,000 hives with American foul brood that needed to be irradiated. It was 1,400 boxes actually. So we were able to take them to Victoria because the only plant was in Victoria at the time, and got them irradiated. So that research funded by beekeepers here through the Research Council led now to irradiation being used worldwide to sterilise beekeeping equipment.
Oh, I didn't know that. That's amazing.
It is, yeah. So it just shows you talk to people, they tell you something, you get the right contacts, things happen. Yeah. So AFB also doesn't only kill American foul brood, kills small hive beetle, American foul brood as we mentioned before, European foul brood, nosema, and also wax moths. So it can be universally used. It's a cold treatment. Being cold, you can keep the combs, so you don't have to destroy the combs because the combs don't get affected. We did research when we want to irradiate pollen because we want to eradicate spores in imported pollen coming in, pollen you collected yourself. So it didn't affect the nutrition of pollen from the research work that was done. So it destroys the DNA in the bacteria, which then prevents them from reproducing. The really important thing about irradiation is that there's absolutely no chemicals used, there's absolutely no residue, so you can irradiate something and put bees in it as soon as it comes out of the irradiation chamber. So that's a real big plus. Cold, so it doesn't melt beeswax at all, so combs can be irradiated. Wonderful thing. The only problem is with plastics and stuff like that, Penny, and we've had experience in this club actually, by irradiating bee suits, the plastic zippers can deteriorate very rapidly and you've got to buy a whole new bee suit or replace the zippers. You've got plenty of good seamstress, they can do that. So you've got to be careful with plastics. Some of the queen excluders change colour and they tend to go brittle over time. There is an issue with flow frames. The dose rate is 15 kilograys. The Sydney plant runs at a higher dose rate than that. So you only need 15 kilograys to kill American foul brood, but the Sydney plant runs higher, which doesn't matter. It doesn't hurt wood or wax or anything like that. You can do it many, many times, but it does with plastic. So it means if you've got a flow hive, you've got to send it to Brisbane. Brisbane can use their plant at a lower rate for product. Sydney can, but it's just the speed, the time the material's in the chamber. So people with flow hives, if you do it at a higher dose rate, the frames just collapse. And probably you can only do it about twice at 15 kilograys, otherwise the frames will collapse. So that's the only disadvantage. With technology, more plastics used in beekeeping, they go brittle if stuff's irradiated. So that can be an issue. Just talk about other treatments, I guess. You can also wax dip boxes. So New South Wales DPI has agreed with the wax dipping of boxes. So it's only for woodwork. You can use a mixture of paraffin wax and micro crystalline wax, and you've got to have a vat, and you've got to heat it up to 160 degrees Celsius, and you've got to leave the material in that vat for 10 minutes. Terribly expensive because the cost of electricity now, and it needs to be thermostatically controlled. So wax dipping is not popular at all in Australia. Yeah, it's more popular in New Zealand and some European countries. If you wax dip boxes, they tend to get sticky in our heat here. They get a lot of dust on them. So it's not really recommended. And if you don't do it properly, some of the spores still survive. In my time in the Department of Ag, we did a lot of trial work. We put stuff through microwaves, but you've got to wet all the wood for the spores to burst. We used high pressure water jets, commercial ones that took all the paint, everything off the boxes. All it did was drive the spores into the wood. And of course the bees, once they get access to those spores, which they will do, the disease shows up again. So, it's a bacteria we know a lot about. And we know that it can only get into larvae, at the right age, between 12 and 48 hours of age. But even with that, it's completely deadly given time. Hives very rarely recover from that disease. And the fact the spores live for so long, it's a real problem. So if anyone buys second-hand equipment, for the cost of the irradiation, which is not very expensive, it's well worth going down that path.
Okay, so Bruce, suits, you're saying we shouldn't be getting them irradiated because it damages the zips, and we've had that problem here. So is it safe to just wash the suits? And what about gloves as well?
Yeah. Look, I'd be tempted to certainly just wash, suits, because the bacteria, wash away. Yeah. And with metal equipment, metal spores can't penetrate metal, so it's possible to extract honey that's had disease, and in fact that has to be done because the other thing irradiation does, it causes liquids to froth a bit, and honey will froth. So there's to be no honey if you're going to get combs irradiated, in the chamber. So that's one of the other disadvantages. So probably gloves, because they're leather, and I'm not aware that leather's deteriorated by irradiation. You can probably irradiate gloves, and it's probably wise to do so because spores can penetrate leather, and the spores can still be there. And you pick up a frame or a hive, and you only need 10 spores. Remember, 10. There's millions in a scale. That can cause an infection. So I'd be certainly tempted to irradiate gloves. Hive tools, because they're metal. The spores can't penetrate the metal, but get wax and bits on them, and I'll talk a bit about hive tools in a minute. So if you're going to extract honey, probably use a stainless steel extractor, and it's important to really wash that out properly. You can use 1% caustic soda, that helps. You've got to, when you're washing the extractor out, use cold water, because if you use hot water, and the temptation is to use hot water, it just welds the wax on. So use cold water first, and then you use hot water after that to get all the wax out, because there can be millions of spores in a little bit of wax.
Yeah.
So you've got to get rid of all the bits of wax off the baskets, off everything in the extractor. Once that's done, that's completely safe to use again because the spores can't get into the metal. Bees don't dig in holes or anything, so the spores get washed on the ground. There's no interest to bees, they're not going to pick it up. Hygiene when you extract honey, and if you extract honey, it's illegal to get it irradiated in Australia for human consumption, but you can eat the honey. There's nothing wrong with the honey, but you've got to be sure, or use it for cooking, it doesn't go into pre-packs, or it can't get into the food chain where bees might accidentally pick it up.
You don't want to be giving your kids a honey sandwich that's got A and B in it.
No, because they might throw it away. That's right. Yeah. So the hive tool I think is a real risk, and we've got to be really careful with hive tools because you're putting them in the hive. And you never poke a hive tool in where you think there's disease, and people tend to do that because it's in their hand. Always use a stick or a match, and always put it in the hive, back in the hive, and leave it in the hive, and then get it irradiated. Or you can cut the combs out. You don't have to send the frames away. You can cut them out. Now, there's no risk with wax, right? Because of the temperature, wax melts at 62 degrees Celsius, but it holds its heat for an enormous amount of time. Many of beekeepers moulded wax in a big mould and kicked it out of the mould, and all that wax has run out because the centre was still liquid. So there's no evidence anywhere in the world that wax is an issue for transmitting American foul brood, provided it's been heated to a block and processed. So I want to make that point. So with your hive tool, you know, when you go from hive to hive, you're better off to clean it. You can put it in the smoker, you know, flame it, and if you flame it, that'll kill the spores on the outside. You can wash it in alcohol, you can autoclave it, but make sure your hive tool's clean between eight hives, or use a different hive tool, you know, on each hive. That's probably the other way to do it.
That's it.
We have a question, I think you sort of covered it, Bruce.
Yeah.
Bradley White,
Yeah.
coincidentally, Bradley White, his name is,
Yeah.
asked about, with the irradiation, is it certain that nothing can be affected in the future use of the boxes?
Yeah, okay, so Bradley, thanks for that question. Look, we did an enormous amount of research, and I was just fortunate enough to be around at the time in the Department of Ag, but I've been retired 15 years, so it's a long time ago, but I remember everything very clearly. So I had these 20 boxes that we kept from young. We took them to Lucas Heights, they irradiated them, and Michael's a brilliant bacteriologist who worked for the Department of Ag, and Pamela Wills, who I mentioned, just happened to have 2 eyes of bees. So she was really keen and understood beekeeping. So they did a lot of work, by Michael supplying spores, to work out what's the right dose rate to actually kill everything, 100%. And prior to that, there was ethylene oxide used. There was all sorts of things used in the States, but none were 100% effective. So New South Wales DPI and my previous boss, Alan Clemson, although it was a decision, we would not recommend anything except burning, and everything was burnt in the past. This has saved millions and millions of dollars. Everything was burnt. The 200 hives we burnt at Young was an enormous fire, and it was done at the tip. By doing that research, that Michael had the bacterial knowledge, Pam had the knowledge of how irradiation works. So with them combining, they worked out the dose rate. I didn't have anything to do with that because I'm just a beekeeper. And we put bees at the Department of Ag site at Camden, which is still owned by the Department of Agriculture, a couple of thousand hectares. And I had the job of watching them, and so did Michael, so we checked them regularly. Now, they could have picked up American foul brood by flying into Camden to rob some honey, but that didn't happen. And we didn't keep them for a short time. We kept them for 2 years. Then we had this enormous outbreak, in a commercial beekeeper's apiary where he picked up wall combs, put them in his supers, and that spread throughout the whole business. He thought it was European foul brood, showed me the frame, said that's American. Then when the hives were looked at, they virtually all had American. So I then decided to let him go to Victoria in semi-trailers which were enclosed and irradiated the stuff there. So I'm quite convinced that with all the work that was done, radiation is 100% effective at 15 kilograms, but it's done at a higher rate because plants run at a higher rate, because a lot of stuff's now irradiated, not only beekeeping equipment. The big mistake we made was not getting royalties. For the apithor traps that are developed by the department, royalties go back to the department and back to the industry for research. But in 1982, we didn't think that we needed to put some sort of royalty on something, but that would have been fantastic because it would have given that much more money, for research to be done for the industry. But I think Stereotech's been reasonably fair, as far as costs go.
I think Stereotech's their pricing to irradiate a box is pretty good. So I think you're right. They have done the right thing.
And they sponsor shows and they sponsor things.
Yeah. Just get you to hold that up, Bruce. We've got the biosecurity manual. If everyone should have a copy of this. If you don't, please get in contact with the DPI. This is a really good book. Shows you some great photos inside of all the different diseases in your hive. Well worth having in your beekeeping kit. Thanks. We've got our next video that we're going to show is unfortunately rather a sad destruction of one of our hives that had AFB in it, and it's the big coffin hive, which again, Bruce, you said it's always the strong hives that get it, and this was absolutely booming. only a month ago, this hive. It was going great guns. We've extracted honey from it twice since Christmas, and sadly it has now got AFB in it, and we've had to destroy it. So we've got a very short video of us pouring the petrol in it last night, and yeah, can we flick to that, please, Emmanuel?
Okay, so the first thing is wait till it's dark, and then you've got to block the hive in so that it's as airtight as possible. Okay, so the first thing is wait till it's dark, and then you've got to block the hive in so that it's as airtight as possible. Righto.
I don't know, Bruce.
Righto. Righto.
Stay close, Bruce.
So that's the shot of the dead bees.
That's it. That's it. Say sorry, Emmanuel stuff up there. 5 seconds. Wrong.
Okay, thanks, Emmanuel. Sorry about that. We had a little bit of a technical stuff up there. Anyway, we're live, so these things happen. Thanks, Bruce, for joining us tonight again, and thanks, Emmanuel, for doing the live stream. Very good, and we'll see you all again.
We've got some questions.
Oh, have we?
Oh,
Okay.
Just some questions from the previous videos, Bruce. Questions without notice.
Righto.
From the swarm video, we've got one from a subscriber called Baddest Bees. I'm almost always find the supersedure cell in a hive with swarm cells. I always figured the pheromone was low due to crowding. Some people say they're still swarm cells. Disagree with what's on your I disagree with what's on your thoughts on this. I almost always find 1 or 2 hive swarm cells. So you want me to read that again?
No, okay. Like, I guess we humanise, what we see, and what we see is that if a colony is going to supersede, there's usually only a very small number of cells, and they're actually constructed as queen cells, and they're normally only present in going into spring or going into autumn. And the test is, you can look at a queen, she looks quite normal. The test is, if you take that queen out and you introduce her into another hive, which I've done, that hive will start swarm cells, supersedure cells too. So the bees can tell when a queen is defective, and sometimes we can't tell that, and sometimes we can. I mean, obviously the queen's not laying properly, real patchy brood, they'll supersede her, and we can tell that. If there's 12 to 15 cells, and they're also constructed as queen cells, the hive's going to swarm, and the number varies, depending on the strength of the colony. They can be on towards the bottom bar, they can be on the side, they can be virtually anywhere in the colony. But 12 to 15, and the colony is strong, right? Because it's strong, it's going to swarm. And then, emergency cells are quite different because they're not constructed as queen cells at all. They're converted worker cells because the queen's been killed, and they've had to convert larvae under 24 hours of age into queens to be able to do emergency cells. So, I don't see you can pick one or two cells out and say, they're supersedure cells, and there's other cells in at the same time, and you say they're swarm cells. That's my opinion on how we see things. You don't get supersedure and swarming at the same time. They're two totally different scenarios in a honeybee colony that the bees have decided, what to do.
Okay, you want to take another question?
Yeah.
Thank you, Bruce. We've got another question from Cornell. Why do you shake bees in front of the hive they come from? Shake them inside. I don't get it. I get it when you shake nurse bees in front of a weak hive, but I don't get why you shake them in front.
Okay, so Cornell, provide the hives on the ground. That's what I do. And the reason I do that is that if I'm shaking bees off, I've got a reason to do it. And the reason usually is to inspect hives for disease. So by shaking them out the front, they're going to take a while to walk in. If I shake them into the box itself, they're going to be recycled by running to other frames. I'm going to have to shake them off again to look at those other frames to make sure there's no bees on those frames. So that's why I shake bees out the front. They happily walk in, and the queen will walk in with them, provided the entrance is such that they can get in okay. But if you've got a hive on a stand, you've got no option but to probably take a couple of frames out, leave the bees on them, and then start to shake in the gap. Because if you shook bees out the front, on a hive that's elevated off the ground, you're going to lose the queen, because queens can only walk in, they can't fly if they're a laying queen. So that's the reason, why I've always done that.
Okay, we've got some more questions. There's a comment here from Sylvie. Really interesting. I hadn't heard of the DeMarie method. Can you put another queen excluder on top and stack honey supers on with two colonies like that? Yeah,
sure, Selby, you can do that. And some smart people, where next door neighbours are agitated because there's bees in the backyard, tend to do that. And it looks like there's just one hive, when in fact with the DeMarie board on a hive there's actually two colonies, because there's two queens in that stack of boxes. The general public, don't know what a hive is quite often, and they often complain if you've got a 3-decker hive, someone's got 3 hives in the backyard. So DeMarieing, is a good system, and if you've got limited space even, you can have 2 hives, but they form one stack. The disadvantage is, the amount of lifting you've got to do, look at the colony on below the DeMarie board. So that's the only disadvantage. A lot of commercial beekeepers, put DeMarie boards on 10% of their hives every winter. So they've got 10% of bare single hives ready to go into spring with, if hives die out through the winter.
Okay, thanks, Bruce. We've got another one here from Rhonda Sava. Bruce, if your hive is full, will adding a second brood box stop swarming?
Yeah, hi Rhonda. Not necessarily so. You would be better off, to put another super on. If the colony's strong, it indicates there's plenty of worker bees there. And as I've said many times, that with 2 brood boxes, you don't get twice the number of bees in the hive, and the hive's not twice as strong, because it takes a lot of body protein to feed brood and a lot of heat to be generated to keep it at 34 degrees Celsius. And it's common knowledge that the life of a bee depends on how much work she does and how hard she works. So by a colony keeping 2 boxes of brood warm, fed and all that, depletes a lot of body protein from the worker bees, therefore they don't live as long, therefore the colony doesn't get super strong. I believe in 1 brood box, a queen excluder and honey supers above that. As far as the swarming question goes, it's often related to the size of the cavity. So by putting another box on, be it a brood box or a honey super, it's an indication that the colony may not swarm because the cavity is larger. But in preference, I would put a honey super on with above a queen excluder, as opposed to putting a box under an excluder to have 2 brood boxes.
Just a comment on the putting down the bees, euthanizing the bees. It is a sad process, Bradley. He's commented it must be a sad, heartbreaking process. So.
Yeah, it's a sad, hard process. We did a lot of work, how do you kill bees? Particularly once we developed irradiation. Once we developed irradiation, we had a need to keep combs, because combs are very valuable to a lot of beekeepers, and it gave us the opportunity to save material, which was saved millions and millions of dollars since 1982, because otherwise they're all burnt, and to save combs. A lot of painstaking work went into looking, how can we kill bees and not leave a residue in the box that's going to kill bees. I mean, you can spray Bagon on it, you can put a whole heap of chemicals in a hive to kill bees, and they kill them instantly. But the residue stays in the wood, stays in the wax for months and months and months, and bees die. So we had to come up with something, and we had a really good chemistry section in New South Wales DPI, spent many hours killing bees, and trying to kill bees. And we had a really bright chemist, and I won't go into all the details, but we tried a lot of stuff. And petrol was by far the most efficient thing to use, because the fumes that kills the bees, it gets everywhere. We had to get a permit, so anything that you use to kill an insect requires an APVMA accredited permit to be able to kill something. So at the time, petrol was new because of irradiation. So I had to collect wax, pollen, get the woodwork checked, nectar, to make sure there's no residues that are going to be toxic to bees and to human health. So that was the critical thing. And then that all went to government accredited laboratory, National Residue Authority lab, and was all tested, and it come back that it was safe to kill bees that way. It wasn't going to affect human health. It certainly doesn't affect bees. It's the fumes that seem to kill the bees. And interestingly, in that time we didn't have gauze bottoms, ventilated bottoms. We've got ventilated bottoms now, and the hive we did last night, it's probably the first time I've ever killed with petrol with a gauze bottom, but I've killed thousands of hives over the time, because we used to be hands-on in the department in my day, and do work with beekeepers, and it still killed them. And I use rag. I've never used rag before, and I think rag's a good idea. And as Penny sort of said, just a while ago to me, it gives a more slow release probably of the fumes maybe. So I would now, and that's not in any of the literature, but I now would be telling people to use rag because you're not getting as much wax on the combs, whereas before we used to pour it in. So I think that's an advantage, and every bee was killed in that hive instantly. New South Wales DPI is now recommending soapy water. I don't think it's all that effective because bees cluster. They're in the process of, and there's a video on it that's done by Doug Somerville. Because bees cluster, you don't get them all. And the idea of soapy water is that it blocks their breathing tubes up and smothers them because they can't breathe. It's important, which you've seen on video, you've got to do it at night when everybody's home. You've got to do everything at night. So soapy water is the other way to do it if you don't want to use petrol. But petrol is just so incredibly effective with the fumes. It just kills every bee. It doesn't have to touch the bee. They're just dead for some reason. Now, soapy water and foam, it's got a really important place with rollovers. Often get trucks that roll over with bees on them, and not often, hopefully not, but we do. And the fireys, all use foam for that, but they're blasting it on the bees and it's blocking their trachea up. They're breaking up the clusters, and that's certainly, an effective way with a rollover that's safe for the environment. Then we don't want to put petrol, on the ground and all that sort of stuff. So I hope that explains that.
How are we going? Any more questions, Emmanuel?
Oh, there are plenty more questions in previous videos, but I'm not sure how much time we have. So just maybe
one more. No.
Just having a look here.
But we welcome any questions on the videos, good or bad. I mean, that's the way to learn.
Yeah.
I'm forever learning, and it's amazing what you pick up by talking to people, learning from people. So.
Well, one thing we didn't show was the little slide that we used last night. So we used the slide, just a glass slide, and in one of these little plastic cases. So you can, if you're a member of our club, we've got a few of these. We can certainly give you one to have in your. You can download that from the DPI.
Just repeat that form you fill in. The camera cut off there a sec.
Oh, did you get this one?
Yep.
Oh, okay. So this is the form, the DPI form that you can download from the website, and you send that off with your slide if you want to get your slide tested for AFB or even other diseases you can get tested as well. So handy little thing to have in your beekeeping kit.
And if you're a registered beekeeper, it's all free.
Free.
You can also get honey samples tested, but they're $40 to get tested. And any beekeeper with over 50 hives under a thing called the Code of Practice is now going to require 20% of all their hives they own, a sample of honey from 20% of all the hives they own, to be tested for AFB spores in honey. It doesn't necessarily mean there's clinical evidence in the hive, but it's an indication that bees have robbed honey with spores, and they may not have fed them to larvae to see the vegetative form, which I explained previously. ABA clubs can get 75 samples tested free for honey samples, and all the clubs have been notified about that. So we're asking for 3 samples from each club. There's 33 clubs in the ABA now and over 4,000 members. Only applies to New South Wales clubs though, because we've got 3 clubs interstate, 2 in Queensland, 1 in the Northern Territory. So it's funded by New South Wales DPI. The last lot we did was 74 samples. 17 samples of honey had spores in them. Spoke to every beekeeper whether it's positive or negative, because I'm the biosecurity officer for the ABA. And of those, 3 beekeepers found clinical evidence in their hives of AFB, and some weren't aware that they had disease in their hives as a result of that honey sample. Get a honey sample, it's got to be a bulk honey sample. You don't get a spoonful out of the comb. You've got to extract the hives and take a sample out of the container, the bulk container you put the honey in. Spores profile evenly in honey. They don't settle to the top, bottom or middle. There's been a lot of work done on that. So if you've got spores in your honey, no matter where you take the sample from, they'll show up. the technology's smart enough to be able to actually count the spores, so you get a spore reading in the sample that you send in.
So, Bruce, do you think if you had AFB, it's like we've had it in the apiary here, do you think it would be worthwhile us getting our honey tested for the next couple of extractions we do?
Yeah, for sure, Penny. Yeah, and I think that should be mandatory for every beekeeper that gets AFB, but it's not.
Yeah.
And that's the best monitoring system, because you're monitoring all the honey in the hive that's been extracted, and you're monitoring all the hives. So you mix, if you extract 10 hives, you send sample from 10, you do 20, you send 20. It won't tell you which hive maybe have AFB, but then you go and look at every hive to see if there's any clinical evidence. And if you get two free samples that have got no honey in them, no spores in them, sorry, it's an indication that you've probably eradicated the spores from that hive. Now, the issue with honey and spores and AFB, because the bees rob it, bring it home, load it somewhere in the hive, and it doesn't affect the adult bees. If you get AFB in an apiary, what you should do is scratch, with a scratcher, a fork or anything, all the honey in all the hives, provided there's honey flow on, or nectar coming in, and use a different fork for each hive, or wash this fork thoroughly before you do the next hive. And that means the bees are going to lick that honey up because it's been exposed. Because it's been exposed, and if they feed that to larvae, it's going to show up in the hive. So you can have a bee, say, someone dropped a jar, they've robbed 500 grams of honey, and they've stored it all in the top super, and they haven't been hungry over winter. That sits there for years until they eat it, and if they eat it and it's fed to the larva at the right age, the spores germinate. If not, if it's stored in the brood box and the bees haven't touched the honey in the brood box, it still sits there until they eat it or feed it. But by scratching it, they spread it round and it'll show up in the hive, the clinical evidence, if the spores are in that honey.
Okay. So you're saying just scratch the ones in the brood box?
The whole lot.
Okay.
Extract the super and then extract the honey in the brood box. Because you're not extracting the honey in the brood box, if you scratch it, it forces the bees to use it. Now, as recreational beekeepers and beekeepers, the majority of the people we're talking to tonight, you can do that. Commercially it's a far bigger job to do that.
Yeah, it would be too much.
It's probably too much, but so if you get AFB, scratch the honey in the brood box, extract the supers, provide this honey coming in, you don't want to starve your bees, and that'll force the hive to show the symptoms. If you don't do that, it can show up 6 months later, 12 months later, 2 years later.
Okay, sounds good. All right, I think we're done.
Thanks. Add the feedback and comments.
Thanks everybody. Thank you. Always welcome feedback too. If you want to put any questions on the bottom of our videos, please do so. Any complaints, anything, any sort of information, please like the videos. If you get a chance, click the thumbs up or thumbs down, whatever you want to do. Hopefully most of them will be thumbs up. We're trying really hard here. And also please subscribe to our videos, then you'll get notifications when a new one has been released, so you won't miss anything. All right, thanks everybody. Thanks. And thanks Emmanuel.
Emmanuel's the mainstay.
Yeah.
Without Emmanuel we wouldn't be doing any of this.
That's right. Good night.